Up next is the application of the stack. Having clearly understood the very operation, the functioning of the stack, it's now time to understand how stack is used in various applications. The first application is pretty simple. In fact, there are just too many, but we'll just keep it down to two. The first one is reversal of a given line. Okay, say you have a sentence, paragraph, or a word which you would like to print it in a reverse manner. So, for the sake of simplicity of the example, let's say you would like to reverse, the Tibet into Tibet. Okay, so with the help of stack, it could be done in a very easy manner. You have the stack, and then you just knew how to write a program for the stack operation, and then starting from the first character, the big T will be pushed onto the stack, followed by I, and then you have B, and then you have E, and then you have T, right? So starting from the first, keep pushing the characters onto the stack, and then pop them one by one. Small t will be the first one to be popped, followed by E, followed by B, followed by I, and then finally you have big T. So this is pretty simple. So in order to reverse a given word, given sentence, given paragraph, if you could write a program with a stack, a given line could be reversed with ease. So this is the first important the application of the stack. Now the second application of the stack is called polish string. So you have this term called polish string, string. So this notation or the format is actually started by a Polish mathematician. I don't remember the name of the Polish mathematician, but so this guy actually came up with a notation or the format in which the expression, these are the expressions which are very much understandable for us. Okay, so this kind of expression is called infix. Infix means the operator are placed in between the operands. These are the operand, A, B, C, D are the operands, plus multiplication, division signs are the operators. So when the operators are placed in between the operands, these are very much, for us, for human beings, right? For us to understand. So this kind of notation is called infix. And then you have postfix. Postfix means the operators are placed after the operand. For example, A plus B is an example of infix. A, B plus. This operand is placed post the operands. Post means the after. Okay? And then you have the prefix. Prefix means the operator is placed before the operands. Alright? So you have three notations. The first one is infix, postfix, and prefix. So polish string is being referred to the postfix and the prefix. So this guy actually came up with a format or the notation called postfix and prefix, in which the operators could either be placed after the operands or before the operands. Now the question is, why do we need the postfix and why do we need the prefix, and how it has a basis to the application of stack. Now for us to evaluate these kind of expression, arithmetic expression like this and this, it's very easy for us. We have this rule of BODMAS, which starts with bracket of division, multiplication, and then these expression, when you look at this, we need to use our human intelligence, to figure out which operation, is to be evaluated first. So when you look at this, we have to use our intelligence. Okay, it has to be the bracket first, these two first, followed by this, that, and then, even though it's simple to us, thanks to our intelligence that we are able to evaluate these kinds of expressions with ease. But ultimately, we assign our tasks to computers. Especially when the program becomes more and more complicated, we take the help of the application or the softwares or the programs in the computer. So the computer software or the programs need a certain way out to evaluate the arithmetic expressions for us. So we are not the one who are going to evaluate those complicated the calculations, be it in any application in and around us. So ultimately it will be done by computer. So computer doesn't have any IQ. They don't have intelligence, the quotient. You need to clearly give the instructions, no matter how minute, how simple they be, you need to give a clear-cut instructions. It's like, giving a clear-cut instruction, very, very simple instructions to some stupid, machines. So computer, after all, it's a machine. It doesn't have any IQ. So the computer needs a very simplistic way to evaluate the arithmetic expression. So it is through the postfix and the prefix, the softwares will be able to evaluate. So when you assign these tasks to the computer, it becomes very complicated for the computers to evaluate. When you look at this, there is no pattern as such. It becomes a little messy for the computer. So computer, since it understands the binary language, it has to operate just one operator with two operands at a time. I repeat, since computer doesn't possess any level of IQ, even though computer performs very, very complicated operation, but at a given point of time, the computer will be able to handle two operands with one operator. Once it's done, again, it goes to the next step. Again, it needs two operands with just one operator. Okay, so likewise, they are able to perform very, very complicated operation. But whatever said and done, the steps are in a manner of two operands with one operator. So when you look at such expression, computer just focuses on this. Okay, A and B needs to be added. Once it's done, it goes on to the next step. As of now, things might not look very clear, but as and when I move further, it will start to become a lot clearer. So now let's learn how to convert the infix to postfix first. Okay. Once you learn how to convert infix to postfix, prefix is pretty much the same. So first of all, let's take an example of a plus b into c divided by d. So this is an example of infix, and we need to have this converted to postfix. And it is the postfix or the prefix that will be understood by the machine in order to carry on further with the evaluation or the calculation. So the rules are, first, you need to use the pair of braces, in order to highlight the evaluation order. When you look at this, okay, it's pretty simple. This will be the first one, okay, and then followed by this and then this. But in evaluation order, in converting infix to prefix or postfix is, it all starts with, the first one will be parenthesis, number one will be parenthesis or the bracket, they mean the same thing. And then number two will be either, it will be exponent, and then you'll have division or multiplication, and then finally you will have addition and subtraction. Okay, so this has to be evaluated first, followed by exponentiation, and then division, multiplication. Just in case, if you have both division and multiplication on the same line, the one which appears first on the left hand side will have to be evaluated first. So let's say you have multiplication and then division. Both have the same evaluation priority. Okay, so the one which comes first on the left hand side will have to be executed first. Same goes with the addition and the subtraction. Okay, so once you understand this, let's try to convert this. Okay, so this is the A plus B. This is the first one that will have to be evaluated. And then you have two operators left, multiplication and division. Like I said, both have the same priority level. So whichever comes first on the left hand side will have to be executed first. So I just put the brace in order to highlight that, this will be the second in line. And then finally you will have the division operation. Okay, so the first step in converting the infix to postfix or prefix is you need to use the parenthesis to highlight the evaluation order. So when you look at this, now it's pretty simple. This will be the first one, followed by this, and finally this. Okay, now let's convert this. So A plus B will be converted to, since it's postfix, operands, will have to be combined first, and then you will have the operator. So A plus B will be converted to AB plus. So this is called the postfixed. And then you have, now this will be, one element, and then into C. You now have this, okay? Now the next step will be, this now will be the second in line. So this will be changed to AB plus. This is the first operand, and this is the second operand, and then you will have the multiplication sign. So as you can see, the operands are grouped together, and then follow the operands by the operator. So this is now one element, and then finally you have the division operator. So this will again be converted to AB plus C multiply D, and then you have this. Okay, so this is the equivalent postfix expression of this infix expression. Okay, so this is understandable to us, but when the machine looks at this, it's literally impossible for machine to evaluate the infix expression because it's pretty complicated. It needs certain level of IQ, but the problem with machine is they don't have any intelligence. But don't be influenced by AI. At the end of the day, it's artificial intelligence, right? Artificial intelligence. So now before I move on to the second example, in order to make the sense of the entire picture, I'll just try to bring the picture of how stack could be applied in the polish string. Okay, now let's say you have the value of A as 2, 3, you have 4, and then you have 5. Just to understand a little bit, but I'll not get into the detailed format of the thing that I'm going to show you right now. But in order to feel a little better, in order to make much more sense, I would like to have an additional element, to angle to this particular example. Let's say if we just go on by our own calculation, so A plus B, 2 plus 3 will be 5, and then 5 will be multiplied with 4, or 5 will be multiplied with 4, okay? So this will be 20, 20 divided by 5 will be, the final answer will be 4, okay? So this, is how we as a human, move on with the calculation of the expression. Now the question is, how machine, calculates this? Okay, this is when the stack comes into the picture. Once you are able to have the postfixed expression, postfixed equivalent postfix expression of the original expression using stack, the computer now gets on with the calculation like this. They come out with the stack first. A is how much? This is 2, 3, 4 and 5. Okay, and then it starts from here, just like how I took the example of Tibet. I started with big T followed by I, B, E, T, is it? So how stack helps to evaluate the postfix is, the rules are, the operands, these are the operands, A, B, C, D are the operands. They will keep getting pushed onto the stack. But the moment you have the operator, two latest operands are popped, the calculation is carried out, the result will again be pushed. I'll come up with the actual operation. The A is the first one to be pushed, so the value of A will be 2. I'm just giving you a brief picture. Don't worry, in the next video I'll be explaining further on this. And then since A is the operand, the value of A will be pushed. And then next comes is the B. The value of B is 3. Since it's operand, 3 will again be pushed. And then comes the operator. When the next character is the operator, two latest operands on the stack will be popped off. They will be popped off like this. Okay, 3 and then 3 will be popped and then 2 will be popped. Okay, 3 and 2 will be popped. Now since the next character is the operator, like I said, it's a binary operator. It needs 2 operands. Hence 2 operands are popped and then the calculation is carried out. The result is 5 and the result will be pushed back to the stack. Okay, so you will have the result of 3 plus 2 being pushed back to the stack. Okay, and then next up is the operand. Since it's operand, it needs to be pushed onto the stack. Now this is not me as a human who is trying to calculate the postfix. The computer uses the stack in order to carry out the actual operation of the postfix. So imagine me as the machine. So since I know how to deal with the stack operation. Now the next up is C. C is very much an operand. Okay, it has a value of 4, so the 4 will be pushed onto the stack, just like how we push the elements on the stack via the earlier program. Okay, and then you now have the next character as the operator. The next is the character. So the rule was, if it's an operator, then the operands, the latest operands need to be popped off. So this is how 4 will be popped first, okay, and then 5 will also be popped. Okay, they will be taken off the stack, and then the multiplication will be carried out. The result of 20 will again be pushed back to the stack. Okay, and then finally you have the D. D is nothing but the operand. The value of D, which is 5, will again be pushed onto the stack. And then finally you have this division operator. So since it's an operator, the 5 will be popped, and then you will have 20. Okay, you'll have 20 here. Okay, so and then 20 will be divided by the 5. Okay, it works something like this. The 5 will be popped first, and then 20 is the next, and then you have the division operator. So 20 divided by 5, the answer is 4, and then 4 will be pushed back to the stack. So as you can see, when the computer actually carries on with the operation, it deals with 2 operands and then 1 operator. Again 2 operands with 1 operator at a time. So the computer needs a simplistic format on the way how to carry on with the operation. So postfix is important, okay, but with the help of stack operation, the machine or the computer is able to carry on with the the evaluation of the postfix. So if you have not understood the second part much, you don't need to worry, because as of now we'll just focus on how to convert the the infix to postfix. Okay, the next session, we'll go further with the evaluation of the postfix. Okay, so now let's focus on how to convert the infix to postfix. Okay, so again, when you look at this expression, you need to use the parentheses to highlight the evaluation order. Okay, for us it's pretty simple. This would be the first, that would be the second, but again, it's ultimately the machine which has to carry out with the operation. So as you could clearly see, the innermost brackets are the first ones to be evaluated, right? So this will be the first one, okay, and then followed by this, and then you need to use the parentheses, all right? So I'll just copy this first, B plus C plus D into E plus F, G, and then H. So this will be the first, okay? Now the question is, because these two are the innermost brackets, so both of these will have to be evaluated first. Now the question is, I have in this brace, in this bracket, the next outer bracket, you have the plus sign, you have multiplication, and then you have division. Plus sign comes down the list of the evaluation order, so this is out of question. You have multiplication and division which comes on the same level of evaluation order. So which of these two will have to be evaluated first? Yes, you're right. The one which appears first from the left hand side is the one that needs to be evaluated first. So in other words, can I have a bracket like this? Okay. Okay, so this will help us to signify that this is the third in line. First, second, and then third. Once it's done, I now have three operands. First, second, and third in the next outer bracket. You now have to decide between plus and division operator. You need to decide between plus and division operator. Of course, it has to be division, right? So this has to be, calculated with G. So again, I can put a bracket like this. Okay, so this is again one way to highlight the evaluation order. And then, once I'm done with this, okay, once I am done with this, I now have this as a whole. Okay, so first, second, third, right, fourth, and then fifth. Okay, fifth, understood? So you now are left with A and all of this, and then finally you have H. So you have two operators of multiplication, and then you have multiplication. So it doesn't matter much, but perhaps we can, highlight this as the next one. Another way out is you could just mark if the brackets, look a little confusing. But as per the textbook, if you could highlight the evaluation order using braces, that's how it's mentioned. So we'll just start with the evaluation order. So I need to take care of this first, okay? So I'll have the A plus two brackets. Remember, B plus two brackets, and then we'll get rid of this. So C plus D enclosed in this bracket will change to CD plus. Okay, I'll just mark it like this, and then multiplied by, be careful with the bracket, E plus F will be changed to EF plus. Okay, I'm now left with just one bracket, remember? Okay, so this bracket, this, and this bracket, they all disappear, and then you're just left with 1, divided by G. How many brackets? 1, 2, 3, 4. 1, 2, 3, 4. Finally divide by H. Okay. Now the next up is I need to evaluate this number. So A plus 2 bracket. So this now I need to resolve this. Okay, I need to resolve this. So it will be resolved as CD plus, this is the first operand and this is the second operand. This is the operator. First operand followed by a second operand and then comes the operator. Okay, so I now got rid of this bracket. Okay, I now got rid of this bracket, but I am left with this bracket. Okay, and then you now have, this is one big operand and then followed by G, and then how many brackets? 1, 2, 3, 4 multiplied by H. Okay, make sure that in between you have equal number of opening braces and the closing braces. 1, 2, 3, 4. 1, 2, 3, 4. Otherwise, if they don't match, then there is a definite problem. And then, okay, now this is the next, is it? So this is the next in line. I'll just mark it. This is the next in line. So it will be converted as, okay, I need to get rid of this bracket, and then you have CD plus EF plus X, the first operand, and G is the second operand, and then you have the operator. Okay, so this bracket and this bracket will disappear and left with 3 braces followed by H. Alright, now it's time to get rid of B as the first operand and this as the second operand. Just mark it like this. Okay, so it's time to get rid of this bracket, right? So A plus, and then you have this bracket. Now these two brackets will disappear. So this is the first operand, B is the first operand, this is the operator. So this is the second operand, CD plus EF plus multiplied by G slash, and then comes the plus sign. Okay, and then you have how many braces left? 1, 2 multiplied by H. Okay, all right. Now after this, now this, is the first operand. I'm left with only 3 operands. This is the first, this is the second, and then this is the third. So this as a whole should be added to A. This as a whole should be added to A. Okay, so how do you do it? A is the first operand. A is the first operand, and then this whole thing, I need to get rid of this. Okay, no problem. Okay, this as a whole is the second operand, and then CD plus EF plus multiplied by G divided by plus, and then comes the plus sign. Okay, you have the plus sign. Okay, I think I got it wrong. Okay, no problem. Okay, and then now I now have the first operand and the second operand converted to the postfix, and then the whole thing, these 2 brackets will disappear, and finally I'll have the H. So this is the first operand, and then this is the second operand, and then this will be converted. How do you convert this? It's very simple, right? So A, B, C, D plus E, F plus into G plus plus. This is the first operand, and then you have H, and then finally you have into. Okay? So this is how you actually convert. Oh, I'm sorry, this is all multiplication sign, remember? I somehow wrote multiplication plus instead of, but it will not make any difference. So you will have here multiplication sign, and then this will be the multiplication sum. Okay, so finally, this is the equivalent postfix of the original infix operation. So it's pretty simple, right? But I would like to show you one more example without the braces. Perhaps you never know if you are more comfortable with using braces or without using braces. It's up to you. Now let's move on to the third example. This is the first, second. Now the third example will be, let me just copy the question. Give me a moment, please. Okay, so this will be the third example, right? So the earlier two examples were done with the help of braces, but you could do away with the braces in order to evaluate the postfix. Perhaps you can start off like this. So understandably, again, you have the these two as the innermost. Okay, these two as the innermost. So you could perhaps mark like this. Okay, this two will be the first ones that will have to be evaluated. So without using braces, okay, evaluate this. So B plus C will change to BC plus. But make it a point to just mark this so that you don't get confused. This plus, between the operator and the operand. And then you have this plus sign, and then this D plus E will have to be changed to DE plus. Okay, like this, and then multiplied by F, and then divided by G. So I'm not using any braces as such, but make sure that you mark the operands as per the evaluation order. Okay, now once I took care of the braces, I'm now left with three operands in the bracket, the next outer bracket, the first one, second, and the third, and then sandwiched with plus and the multiplication. So which means, I need to multiply this with this, because the plus, the operator, the evaluation order is below the multiplication evaluation order, right? So you will have A plus, okay, BC plus, and then plus, I need to multiply this with F. So DE plus, second operand is F, and then comes the operator. Okay, so don't miss the bracket, okay, and then you have G. Please take care of the bracket, otherwise you may mess up with the order. And then, even though I have division here, but you still have the parenthesis of the bracket. So the first operand needs to be added to the second operand. And then you have BC plus as the first operand, and then DE plus FX as the second operand, and then followed by the plus operator. Okay, and then you have G here. So I'm done with this. I'm now left with the first argument of A, and this as the second the operand, and then this as the third operand. So you have plus and then you have a division. So understandably, the division should take place first. So you will have A plus B, C plus, copy the whole operand, DA plus F, multiplication plus, and then comes the G, and then you have the operator. Okay? And then finally, I'm left with two operands, and then just add it like A, this is the operator, A, B, C, copy the remaining operator, D, E plus F, X plus G division, and then comes the plus sign. Okay? So this is how I convert the original infix to the ultimate, the postfix expression. So once again, if you could recall the evaluation order, the first one is parenthesis, the second one is the exponentiation, right? Somehow I missed the exponentiation. Okay, no problem. Exponentiation, and then you have the third one as the multiplication or the division, and then finally you have the addition and the subtraction. Okay, and then finally we'll come up with one more example using the not. You have not A or. Just get rid of this. We'll take another example of not A or not B and not C. Okay, this will be the third example. Now this time, unlike the earlier three examples, the not, or, and are the operators. The plus, multiplication, these are arithmetic operators. We have relational operators like greater or less than, is equal to, not equal to. Likewise, we have the logical operators. So not, and, or, they are operators, but specifically they are nothing but the logical operators. Okay, I hope I don't need to explain much about the logical operators. So again, just like you have the evaluation order for the arithmetic operators, you have a certain evaluation order for the logical operators, and that is the evaluation order is not comes first, and then followed by and then finally you have or. Not and or. So not is the first one in line, followed by and then finally you have the or. Okay, so now this is again nothing but an example of the logical expression. Okay, these are arithmetic operation. Since the operators are arithmetic operators, this is called logical expression. So again, you'll have to use the braces in order to highlight which is the one that has to be executed first. So I've just copied this and then not C. So you'll have to put the braces first, right? So understandably, not comes first. So not is a unary operator, remember? So not of A, not of B, not of C, are the ones that will have to be executed. And then once I took care of the not operator, the next in line is and. So I now need to apply the and operation between not B and not C. Hence I'll put one braces like this. Okay? And finally, when I'm done with and, I'm left with or. I need to or this, not of A with not B and not C. This is the first operand and this is the second operand. So I'll just put one big brace between the first operand and the second operand. So the idea is, if you highlight the evaluation order with the braces, it becomes very easy for us because we always tend to evaluate the innermost first. So this is, these are the innermost the braces. So again, this is an example of infix. You have the operator in between the operands. you have the operator in between the operands. But since not is a unary operator, it just needs only one operand. Okay, so not of A, again, just like the earlier two examples, not of A will change to, okay, remember the operand first and then followed by the operator. Okay, the operands followed by the operator, operand followed by the operator. And then say I have this OR, you have this bracket, big bracket, and then not of B will change to B not, okay, and then I have and then not of C will change to C not, and then don't miss out on, you have this big opening bracket, remember, okay, you have this, and then look at this, not of B has been changed to B of not, hence I get rid of these two brackets, okay, not of C has been changed to C of not, hence I got rid of these two braces, okay, so I'm left with two more braces, okay, so again when you look at this, you have one more innermost loop, okay, thanks to the AND operation, which follows the not. And then how do you convert this? You have this A not OR, okay, so this is the first operand and this is the second operand. So B not, okay, this is the first operand, C not is the second operand, and then comes the operator, which is the AND operator. Okay, so be careful, and then I could get rid of these, the pair of this bracket. Since I resolved this, I can get rid of these two braces. I'm now left with only one closing parenthesis. So it's a good idea if you could mark, otherwise you may get confused. This is the first element, and this as a whole is the second element. And then finally, when I OR the first operand with the second operand, again, it's going to be the same format. Just copy A not, okay, and then copy the whole thing, B not, C not, and, okay, this is the first operand, second operand, and then in between you have the OR operator, and then you will have OR here. So this is nothing but the postfix, the postfix expression, equivalent postfix expression of this original infix, right? I should have had the exponentiation, but I've missed it. I don't know, maybe I must have messed up while copying the question. But the fact is, just in case if you have exponentiation operator, so this is the exponentiation operator. Say if I have A exponentiation operator B, this as a whole is to be executed before the multiplication and division, right? The order is, remember, the parenthesis, exponentiation, and then multiplication, division, and then followed by the addition and the subtraction. Okay, so with this I would like to wind up, but as a matter of quick recall, what we have learned is today, I actually started with the definition of stack, and then how stack operates via diagrams. 5 key terms: the push, the pop, the peak, underflow, and then you have the overflow. Overflow is a rare situation in the data structure implemented through the list, because in Python the list could grow infinitely. So which means, unlike in the earlier programming languages where we have used arrays where we could specify a limit, in which case you do have a situation of the overflow. Okay, but in the list, in the data structure, specifically in the stack, since list could grow infinitely, the overflow takes place only when the memory gets exhausted. Okay, and then underflow means when the list becomes empty and then you try to perform the operation of peak or the pop. This situation is known as the underflow, right? And then we came up with the big program, which explained to us how the stack actually operates And then two very important applications of stack. The first one is the reversal of a given line, and then how to convert the infix to postfix. But when the machine actually carries out the evaluation of the postfix or the prefix, that's when the application of stack comes into the picture. I just showed you in a very brief manner how stack as an application is used to evaluate the postfix to come out with the ultimate solution or the ultimate answer. But I did it in a brief manner, but no worries, in the next class I'll be explaining you in a little more detailed manner. So with this I would like to wind up. Take care and thank you very much.